Okay, so again, got an equation here. It's a linear equation. First powers of x, first powers of y. And you know how to recognize that, I think. And we can find the intercepts, which is pretty straightforward. Seems everybody did that well in homework. So now we can draw a graph with 2 points. And there's a straight line. Okay. And that straight line, if we've got it right, if I had it just a little higher, or if I, yeah, so here, I'm going to make it better. There's 6, 0. And here's 0, 2. Okay. Well, let's just see what good that straight line is. Let's say we want to estimate the value of y. Okay, well, there's 3, there's 2, and there's 1, and there's 4, and there's 5. Okay, now this is 2, so there's 1. And of course, we could have 1/2 and 1/2, right? Okay, if I want to estimate the value of y when x is 2, okay? How do we do that? Well, here's 2, that's x is 2, and we just find the point on the graph where the x coordinate is 2, which is going to be right above or below 2, right? And then we come over here and find the y coordinate. And it looks like the y coordinate is pretty close to 1.5, right? So this point, then, if we just look at these coordinates, would be the point 2, 3/2. Now let's see if x equals 2 and y equals 3/2 satisfies the equation. And I'm going to ask you just, just to keep you engaged, although you look pretty engaged. Substitute those values in, see what you get. Okay, we did pretty well with this. Just to be clear, you got to put this 2 in where x is with 3/2 with y, right? So the point 2 means x equals 2, y equals 3/2. So to write this out in detail, x plus 6y equals 12. Well, we plug 2 in for x and 3/2 for y. We get 2 times 2 plus 6 times 3/2 equals 12. Now, off to the side here, I'm going to calculate 6 times 3/2. Okay, that's 6 over 1 times 3 over 2, right? And that equals 18 over 2, which is 9. Okay. And that'll always work. And sometimes there are shortcuts you can take, because if you're taking shortcuts, be sure you understand why they work. Okay. It can be convenient, like to divide the 2 into the 6 right here. But there's plenty of ways you can go astray with that if you don't completely understand that this is gold standard for that calculation. Okay. Now the 6 is contained there in that 18, so you could have divided the 2 into the 6. Don't be doing that unless you understand it or unless you're really clear on the rule. Okay. Okay. So anyhow, 2 times 2 is 4. This is 9. And you get 12, right? So you get 13 equals 12. This is close. So fair estimate is pretty good. Now, you know how to solve linear equations. Okay. The actual y value for x equals 2. You got 2x plus 6y equals 12. If you substitute x equals 2 for x, and you get 2 times 2 plus 6y equals 12, which is 4 plus 6y equals 12. So 4 plus 6y minus 4 equals 12 minus 4. 6y equals 8. So it's 6y over 6 equals 8 over 6. Can you write that as 6 over 6 times y over 1 and see why this is equal to y? Not because you can draw a line through the sixes, but because of the rules of fractions. Okay? And once you get really used to the rules of fractions, well, you can kind of skip that step, but don't be skipping it until you're sure you understand it. Okay? So you get y equals 8/6, which partially reduces down to 4/3. Okay. Now, 4/3, that's 1 1/3. I estimated 1 1/2. Okay. My actual projection line came a little below the 1 1/2 line. It could have been 1.4. Still wouldn't have been completely accurate. If I put 1.4 in here, we would have been a little closer to 12. Okay, but we still wouldn't have had it. Because, you know, this is 1.3 repeating, 1.33333. Okay, forever. It's 4/3. And you're not going to estimate 4/3 if you're estimating a decimal. Okay, you'd estimate maybe 1.3 or 1.4 if you had a good graph. And even 1.5 for a hand-drawn graph, where I can't even hit the points, wasn't bad. That was close. There's not much difference between 1.3 repeating and 1.5, which is pretty high. Okay. Okay, now my main point here is just that your graph shows you what's going on. You can use your graph to estimate solutions. A rough estimate is okay. And then solve the equation. And if the equation comes out y equals 74, you know something's wrong. Because you know if you go from this to this, you're not going to end up way up there, right? Okay. So there's a huge advantage to being able to sketch or visualize a graph and see if you're getting a reasonable solution. And I'll expect you to be able to do that. Okay. Okay, so here we've got the same graph we've got here. I want to talk about the slope of the line. And when I asked what words go along with the idea of slope, took a little while, had to give a hint, both start with R and then people, oh yeah, rise and run, okay? So most people have seen that. And that's the concept of slope. There's a formula for slope, and your book is going to be big, or your open math is going to be kind of big on that formula. I dislike that formula because it doesn't invoke the ideas of rise and run. It represents it just fine. It's a way of calculating it without understanding it. I'm not big on doing calculations without understanding what the heck the calculation means and what motivates it, okay? Now, maybe their assumption is you see the formula and you'll just understand that. That's like after full feathers, okay? If that's what they're really thinking, I don't want to put thoughts in their brain. Because the guy wrote this stuff, you know, and so forth. It's pretty good. I mean, I pretty much like what he's doing. Okay, but I don't like too much reliance on formulas because they bypass understanding. Okay, well, I'm off my soapbox now. Slope of the line is rise over run. So what do I mean by rise and run? Well, this is not a standard mathematical term or tool, but I think it's pretty much essential all the way through calculus, okay? Not essential, but I think it's really helpful. And that's what I call a fundamental triangle. Okay? And I'll just illustrate the fundamental triangle. You just go from this point to this point. Well, got a right angle here because this side is parallel to the x-axis and this side is parallel to the y-axis, okay? Because parallel to your coordinate axis, you got two legs, and here's the rest of the triangle. This is a fundamental triangle. Point 0, 2, and 6, 0. You do a fundamental triangle for any 2 points, wherever they are. And they don't have to be intercepts, okay? So we'll deal with intercepts because it's actually a little easier. Okay, now, the run, well, let's be careful now. You got to be careful about signs, okay? So we're either going to start at this point and end at this point, or we're going to start at this point and end at this point. So we're going to have a vote. And there are 4 of you, and if 2 of you vote one way and 2 of you vote the other way, I'll flip a coin. Okay? Tell me, do we want to go this way or this way? And I'm telling you, it doesn't make any difference. Everybody wants to go this way because we're used to reading left to right. But if you go this way, it still works. As long as you do it. Okay? So I'm going to go this way. Okay? I didn't say which way I'd go after you voted. I figured you'd vote this way, but I want to illustrate why you can, usually you will go this way, okay? So I want you to go this way. If you happen to go this way, it's not going to hurt anything. So I'm going to do it this way. I'm going to do an arrow here. This point to this point, right? And now I'm going to do arrows here that get me from this point to this point, okay? So if I want to go from this point to this point along this path between, with the 2 legs of the triangle, show me, just point, which way should the arrow be pointing on this side? Yeah, if it's pointing this way, I don't get to go anywhere, right? Okay, it's going to be pointing this way. And then I should have given you the opportunity to show off and tell me, but you would have told me this. Okay, so there we have it. Okay, that's our fundamental triangle. Now I'm going to bring it down here so I can label it a little better, okay? So here's our fundamental triangle. And this point is 0, 2. This point is 6, 0. Okay. The rise is this, okay? So what's the rise? Now, the rise is 2. To get from here up to here, well, here our y coordinate is 0, here our y coordinate is 2, and we're moving in the y direction. So the rise is 2. Now I'm going to say the rise is the y coordinate we end up minus the y coordinate we start at. When I drive up the interstate tomorrow, okay, if I start at exit 17 and exit at 221, okay, my displacement is 221 minus 17. It's a positive displacement. I'm going, my mileage, the mileposts are going up, okay? Right? Now, when I come back, I go from 221 to 17, right? So what's my displacement there? It's negative. It's going to be 17 minus 221. If you start out the day with $100 in your pocket, okay, and end up the day with $20 in your pocket, which happens too often, okay, although most people use credit cards. And you talk about your credit card account too. But then the change in your amount of money in your pocket is negative $80, obviously, right? That's what you get if you do what you end up with minus what you start with. Okay, so it's what you end up with minus what you start with. If you start with $100 and end up with $250, maybe you're playing blackjack. Okay, and you had a good day. So your change would be plus $150, 250 minus 100, not 100 minus 250. So just common sense, but common sense doesn't always transfer over to this picture, right? But the common sense is you subtract where you end up with, well, you subtract where you start from where you end up, okay? So your rise is 2 minus 0 equals 2. Your run is what? Where do you end up? Here. What's your coordinate at this point? Okay, you can't say, but you, yeah, you adjust it, right? Okay, very good. Okay, yeah, it's 6. Where you end up with is 0. Well, that's 0 minus 6, which is negative 6. And of course, negative makes good sense because going in this direction was just a negative x direction. That's a positive direction, so I'll put it implicit. Okay. So now, what's the scope? We'll write it down. Start by saying and fill in the rest. I'll pause here for a minute. Okay, everybody looks good on this. Slope is rise to fun. This class over here has way too much fun. I think.
I was there yesterday.
Yeah. But a bit. No, it was fine. I was just gonna. If there's a bunch of guys in there just having a ball, which is kind of what it sounded like. Yeah. I was gonna say, hey guys. But, interacting with the instructor, you can get as rowdy as you want, I'll just pull the door. Okay. Now, and that's what I was going to do anyway. Just okay. And sometimes people do get in there and it gets a little out of hand. I had one case where somebody just yelled. And I don't think it was in this class, might have been Will Gallagher came down here. He called security or something. Yeah, no, Will doesn't need security. Will's a strong, good sized guy. But, you know, he was a student of mine, but he's still getting up in years. Yeah, 20 years less than what I've got. But, okay, anyhow. I wasn't sure what to do, but I didn't hear any responses and I didn't hear any screams or anything, so we just let it go. Okay, anyhow, rise over run is 2 over negative 6. Okay. And that, of course, reduces to 1 over negative 3, which then is just negative 1/3. Okay. Probably stop at 1 over negative 3. You probably really want to put that down there because now we can say, well, that's approximately that. Negative 0.33. Okay. I wanted it to be an equal sign instead of an approximate equal sign. I put a bar over that. Repeating. Okay. But that gives us a number that we can associate with. Now we can understand 1/3 at this point. A lot of times you'll have a fraction that you can't really make really good sense of. You don't really know how big that number is until you convert it to decimal. Okay. So we don't mess with mixed numbers. Can't think of a case where you really want to use a mixed number. Okay, then I put and I'll go with the decimal. in a box next to the hypotenuse here, indicate, just in a picture, we can just immediately spot what the slope is. We can immediately spot the rise, the run, and the slope. We don't have to go through a bunch of calculations and sort things out. Our eye immediately understands what the slope is, okay? So up here, I'll put the negative 0.33. I might put negative 1/3 because that's again an easy fraction to understand. Okay. Okay, so now we've got the slope. Everybody okay with this? That's how I really prefer to see it written out right now. It reinforces things. I wish, as good as my preparation in algebra and graphing and analytic geometry was for calculus, in my high school, this triangle is so important in calculus and also in pre-calculus that I wish somebody done this. Not that I had a huge amount of trouble sorting out this thing called the derivative and all the y and all the x and all that stuff. It would have been easy for me to sort out. It would have saved me PR. I had to keep the money. Okay. Okay, so now y equals mx plus b is the equation slope m y-intercept 0z. Okay. So immediately, you tell me what the equation of this line is. Okay? Because we just calculated the slope, which is we calculated the slope. It's off the screen, but we calculated it was negative 0.33. And actually, we can go ahead and put that here. We can fill in that triangle and put negative 0.33 here. And right there's all the information you need to write the slope intercept form. Okay? So, sort that out and do that. Okay. So, in this case, I've already got it. So that one thing I say, it's okay to do decimal approximation, see how big this thing is, but you're going to write the equation, write the fraction. Okay, so it doesn't hurt to write this as negative 1/3 equals negative 0.33 for all the information. I should have said that earlier. Okay, so okay, well. M is negative 1/3. And B is 2. Right there it is. There's your y-intercept, 0.2. That's what the meaning of B is. And there's your slope, which is negative 1/3. Now, I don't think I've done it. Solve the original equation. Which is 2x plus 6y equals 12 for y. What you got? Okay, so you get 2x plus 6y equals 12. We have rules. Got to do with the rules, right? So you're trying to solve for y, and this is a little unfamiliar because you don't have a number here, right? But when we solve for y, we want to get all the y terms on this side and everything else on the other side, okay? In this case, not just numbers on the other side, so a little bit of a curveball in this. So if you didn't know what to do, that's okay, but here's the way it's going to be. You just do 2x plus 6y minus 2x equals 12 minus 2x. Okay? And then 2x minus 2x is 0. You get 6y equals 12 minus 2x. Then you divide both sides by 6. Be careful, you don't try to get rid of that 6 by subtracting it. You know, you get there. You solve a lot of equations for time. You get this, okay? So 6y over 6, put some dots. I'd like you to fill in the details there. But I'll focus on this. This is like 1/6 times the quantity 12 minus 2x, right? So it's 1/6 of 12 minus 1/6 of negative 2x. So we write that as 12 over 6 minus 2x over 6. Make sure you understand that because it's a common source of error. You divide the 6, some people, often people will divide 6 into 12 and think they're done and ignore the fact that the negative 2x is also divided by 6, okay? But plenty of ways to be confused on this, so you want to be careful. So that's 2 minus 1/3 x then. That's straightforward. 12 2. 2 over 6 is 1/3. Okay. And now let's see. How does this compare with this? Well, they're exactly the same, except they're in slightly different form, because I've got the 2 minus the 1/3 x here, where I have the negative 1/3 x plus the 2. But I've got the 2 as one term, and the negative 1/3 x is the other term, and addition is commutative, it doesn't matter what order. So okay, these are the same. Okay, well, you want to understand that example as thoroughly as you can because it's pretty much a synopsis of what you need to know about straight lines. Okay. Just to recap, once you have the equation of the line, you can plug in x and find the y value for any x. Okay. You can also, if you want to find the x for any y value, you can solve that. Just plug in the number for y and solve for x. So you can see from this equation or the one that we started with, if I plug in a number for y, I'm going to just have a number here. It's easy to solve for x, right? Or if I plug in a number for y here, it's going to be easy to solve for x. And I'll get the same solution over here because this equation is also equivalent. Okay. Equivalent to this because that's where this came from. Okay, so all these three are the same. And the point is that mainly that this is the same as this. Okay, the slope intercept form is the same as the standard form, where it's easy to find intercepts. Okay. Now, there's another form of a straight line. And they'll rearrange some boards. I'll pause for a second. Also see if there are any questions. Okay, so. Nice and horizontal. Okay, here I've got to the point we'll say is 5, 3. And up here the point 14. 8. Okay. Now we can hit that x-axis. That curve is just not. Okay. Well, let's just go through this. I'm going to ask you to do this. Find the slope. See what you do about finding the slope. Okay, find the slope. We're going to use a fundamental triangle. Reinforce this triangle, which is very important throughout calculus. Okay? And pre-calculus as well as calculus. So we've got this, and we've got what's the run? Well, we're going from x equals 5 to x equals 14. And I can even, and here's 5, here's 14. Over here is 8, and over here is, there's 3, sorry, and this is 8. Okay? So we're going from 5 to 14, so the run is 14 minus 5, which is 9. The rise is 8 minus 3, which is 5. And I advise you write out everything that I write out here, instead of using a formula, okay? The slope is rise over run, which is 5 over 9. It only takes most a minute. If you're practiced with this, you can do it in 30 seconds. It's worth the 30 seconds. And I'm convinced that in 90% of the cases, it'll be valuable to you when you get into something that's otherwise pretty confusing. Okay? I haven't tested that. I probably do PhD research in education, which doesn't take much, on that question alone. Okay? By doing a big sample of students, I had a big sample of students to work on. Then I have to run all kinds of psychological tests. And I'm not going to do something like that. Okay? So I'm kind of assuming it. It's not something that's. Okay? Yeah, well, okay. You got to choose your direction, okay? That's where your question's coming from. Remember I said draw these little arrows and then I didn't do it? Okay? There's an arrow that takes us from one point to the other. I showed you last time, it doesn't matter which direction you go, as long as you go in the same direction here and here. As long as this path starts and ends at the same points as this path, okay? So it doesn't matter what your quadrant is. Just quickly, if we had a point -7, -16, and let's just do this, -15, 4. Okay. Then we draw our triangle. And we choose a direction, which is usually left to right, but it doesn't matter. It's going to be the same either way. But if we choose right to left, we're going to be subtracting in a different order. Okay. Just whatever order works here. So what we're doing is this is your x coordinate minus your x coordinate. See what I said it wrong. It's where you, yeah, I was right. It's where you end up minus where you start, right? So you're ending up here and starting here, and it's your x coordinates. It's -7 minus -15, which is 22. No, which is 8. Okay. I'll blame it on the math because that's just a brain deal. Okay. Now, from here to here, where you end up with is where you end up in y is at -16. You start at 4. So it's 4. Sorry, -16 minus 4, -20. This is your run. This is your rise. I want you to write it out more coherently, like I do. It's also good to do your projections and see where these points are on the x and y axis, so you're sure that you're subtracting the right things. And then you just go from there. You rise over, you run -20 over 8, reduce it down to -5/2, -2.5, -2.5. Okay. So the scheme works, whatever quadrant you're in. And once more, it doesn't matter if you want to go in this direction, feel free. As long as you go in this direction and this direction. Okay. So we find the slope. You get 5/9. So I'm going to write down m equals 5/9. Okay. And then I'm going to write down, and watch this. This is the big step. Y equals mx plus b, so y equals 5/9 x plus b. So you've got one of the two numbers you need to have an equation. You need a number for b. How are you going to get that? That's a big deal. Okay. Got to find b. Once you got m, once you got this, if you got a number for y that corresponds to the number for x, then you have an equation that just has numbers along with b. You have a number for y and a number for x, you're going to be able to solve for b. We should illustrate that. Just take 5 and 3. Okay, y equals 3 when x equals 5, right? Yeah, hang on a minute. Okay, I had a quick question. Would it matter if we use these coordinates? And the answer is no, you're going to get the same result. Okay. Probably not going to have time to do that, but I'll probably write it out just to have it on the video. From that. So y equals 3 when x equals b. So 5, which is your, 3, which is your y coordinate, that's your y, equals 5/9 times x, which is 5, plus b. And now we have an equation we easily solve for b. Now I'm going to run through that solution, make sure you understand. We're officially out of time, so I'm going to just write this down. I'm kind of skipping stuff here when I do 5/9 times 5 is 5 times 5 over 9 times 1, which is 25 over 9. That shouldn't give you too much trouble. Now I've multiplied every term in the equation by 9. Don't forget to multiply b by 9, because if you don't, you're going to get something ridiculous, okay? Okay. And that gives me 27 equals 25 plus 9b. So that, and I'm not going to write out the steps because you understand I subtract 25 from both sides, I get 2 over here. it's pretty easy to see that we're going to get B equals 2 knots. Now, if you're doing this, I want you to write out the steps, okay? So, y equals 5 9 f at 5 9 f plus 2 knots. Okay. Well, without saying anything, I'll work it out to this point. I'm going to get a different number for B here.
That's wrong.
I don't know, I might have screwed something up terribly. But, oh, it's 5B, but that's even worse. Okay. I'll reconcile that. If you need to go, I'm gonna let you go. I'll write the rest of it down. Okay, that didn't work. And for a simple reason, I wrote down 9/5 instead of 5 9. I've corrected that and now it works. Okay. I mean, you can, lots of ways you can check this out. This equation pretty much has to be correct because you plug in 14 here and 8 here, multiply both sides by 9, you get, that's right, 14 here and 8 here. And 9 times 8 is 72. 5 9 of 14 is 79 and 2 9. 79 and 2 9 adds up to 72 9, which is 8. So the two sides check out here. Whether you understand that or not, you can do it. Write it out if you want to. Using 14 8 to do this step, we just plug in 14 and 8 rather than 5 and 3. Then we do the arithmetic, multiply both sides by 9 to get 72 here and 9b here. And 5 times 14 is 70. Okay. And then we subtract 70, we get 2, divide by 9. Again, we get 2 9s, the same as we did over here. So that just shows that it doesn't matter which of the 2 points we use. So I picked the one with the smaller numbers, which usually is a little easier to deal with if you're doing it by hand.